All right, so I've had a couple of people ask me how to solve problem 10.27. So I thought I'd take a moment to go ahead and address that. We are using the law of conservation of energy. So if we go ahead and pull some of the materials that we've gone through in class in the last couple of days, we can look at the fact that the total work done on the system is equal to our change in kinetic energy. Well, our total work is made up of both our dissipative forces and our conservative forces. Doing some rearranging, we are going to get the fact that the work done by dissipative forces is equal to our change in kinetic energy minus our work done by conservative forces. We know that the minus the work done by conservative forces is equal to our potential energy. Right? So that gives us this particular equation. Well, we know that there is no change in kinetic energy because we have a constant speed. So as a result, we are looking at the fact that this particular term goes to 0. Right? The dissipative forces, or the dissipative work, is accomplished by the friction. We can look at the fact that we have the frictional force times the displacement. Well, the displacement is the length of our slide. We are then looking at the cosine of the angle between them. Right? Well, friction is going to be moving up the slide while the displacement is going to be going down the slide. As a result, we are going to see the fact that the angle between them is 180 degrees. Cosine of 180 degrees does give us -1. As a result, we can rewrite this as the fact that negative friction times the length of our slide. But we're not done. All right, that was just what's going on with the dissipative forces. We can then look at the fact that we do have our change in potential energy. Well, a change in potential energy, we are looking at a change in height. All right, our final height minus our initial height. All right, well, our final height is the ground. All right, that's 0. So this particular term does go to 0. Well, as a result, I do get this little negative HI. So when I do some algebraic rearranging, I get negative MGHI. Well, now I have negatives on both sides of the equation. What happens to those negatives? Well, hopefully you said they go away. So I have my frictional force times the length of my slide is equal to the mass of my child times gravitational acceleration times the initial height of my slide. When I do some rearranging, because I'm not interested in what is the dissipative force I want to know what is the frictional force using this method. When I do that, I get frictional force is equal to mass times gravity times my initial height divided by the length of the slide. From here, I can then plug in what the information that I know. I know my child is 27 kilograms. I know that gravity is 9.8 meters per second squared. I know that my slide was 4 meters tall. And that it was 8 meters long. When I go ahead and plug all that into my calculator, I get 132.3. All right. Let me rewrite that. It's a little hard to see. Hard to fit all my information. I have 132.3, and this is a frictional force, so this is measured in newtons. So all in all, that's the process that we would go through to use the conservation of energy to determine what is the frictional force provided by the surface of the slide.